RoamFree, an autonomous two-wheeled URDF robot created using ROS2 Foxy and entirely simulated within Gazebo. The first sensor this robot is equipped with is a LiDAR, which was done using the ray sensor from ROS. As you can see, it is the red dot on top of the robot, and it simulates laser rays that can be used to detect any object in the way. So as you can see, the rays are pointing towards the objects, and whenever they're returned, it results in an object being detected. To better visualize this, let's see it in ARVIS. So as you can see, any of those red dots represent that an obstacle has been detected. So if we drive it around a little bit, it can give us a better understanding of how, as a robot explores the map, and how it discovers new obstacles. Now, the next thing the robot is equipped with is a depth sensor. So, unlike your regular camera that takes pictures with colors like your phone, is good for recognizing objects around you. But with a depth camera, you could take pictures with color and distances. So it shows not just what's there, but how far away things are. And it's great for robots to understand what the 3D world is like, to basically understand if something is close or far. With the use of Point Cloud 2, you can visualize what the depth camera is seeing right now in real-time 3D as you drive closer. As you can see, the cones that are closer, you could see as dark gray, and the cones that are further away will have a lighter shade of gray. This allows us to basically understand how far each cone is. Along with that, the robot can also be controlled with a controller, as you can see. Now with the good stuff, we're going to be using Slam Toolbox to basically create an entire map of the little obstacle course I had created with cones. This was done with me using Slam Toolbox in the background while driving the robot around the map. To show you the robot's autonomous capabilities, first I will load up the map that we had just created using Slam. And along with that, I'm also going to add another map, which is a cost map. A cost map is a digital map for a robot that assigns different costs to areas. So lower costs mean easy movement, and higher costs mean that there's obstacles around it. The robot uses this to find the best path without colliding into obstacles. So as you can see here, all the color schemes represent that there's obstacles present. So for our case, each of those little circles represent a cone. And now I'm going to set a 2D goalpost or where I want the robot to go autonomously. And as you can see, it has already started moving. So just wait, I'm going to speed it up here a little to show you that it gets to where it needs. Now I'm going to set another waypoint here. I want to bring it back to where we started, so near that end. So as you see here in Gazebo, how the robot goes through each cones. Note that all of this has been done autonomously without me touching it. Another cool thing the robot has is that if you set a waypoint here, so let me just set it there, and the robot's autonomously driving, and say I don't like what it's doing, I can take full control using a remote control. So yeah, here I am controlling with the remote. And as soon as I let go, Nav2 takes control, and it'll ultimately end up where we want it to go. Now, on to one of the coolest features, which is object detection. So I've used OpenCV to basically track for a green ball. And as soon as the robot locates it, so as you see in the camera here, as soon as it locates that there's a green ball there, it starts going closer and closer to it until it gets close enough where it has to stop. So as you see here, I'm going to place the ball somewhere else from its current position. It finds it and gets closer to it and stops.